Hello everyone, welcome back to another video of Convergency, and in this one we'll talk about the numericals. So without wasting more time, let's dive into it. Alright, so before I start any of the questions, there are some things which we need to keep in mind. First of all, that whenever we read a question, we will draw a diagram for it. Okay, because with a diagram, things become clearer, and I'm sure your answers will be correct if you draw the diagrams initially. Obviously, with practice later, you can cut short on the diagrams. All right. The second most important thing is that always draw the longitudes and the arrows, as I discussed in the previous videos. We will talk about a property of parallel lines which will be very handy in these questions, and I'll talk about the property as and when it comes in the questions. So let's start with the first one. It says that the initial great circle track from A to B is 080 degrees. The Rhumb line track is 083 degrees. What is the initial great circle track from B to A? A to B was 080. Okay, so we want to know the initial great circle track from B to A and in which hemisphere are the two positions. Perfect. So, first of all, let's say this is A and I don't know where B is. Now, all I know is that from A to B is 080 degrees. I don't care if it is a great circle track or a rhumb line track. Okay, doing the questions, all I care about is this 080 degrees. So, from A, 080 will be somewhere in this direction. Yeah. So I have B over here, which is approximately 080 degrees. I don't know which hemisphere this is. So let's just draw a rhumb line track between A and B. The rhumb line track is also given A and B, which is 083. But before I continue, I need to make the longitudes. So longitude of A, longitude of B. And I'm going from A to B, so this arrow. Now, let's consider two situations. Number one, it is the northern hemisphere. Number two, it is the southern hemisphere. Okay, so if it is the northern hemisphere, it will be the green great circle track. If it is the southern hemisphere, it is going to be the yellow great circle track. Now, let's see which one makes more sense. So, as per the question, initial great circle track A to B is 080 degrees. All right, so starting from the longitude, first to the green one. This looks like less than 90 degrees to me, so it can be 080. Whereas if I talk about the yellow one, it looks almost 090 in this case, or it can also be more if I make the diagram properly. So looking at the diagram, it becomes a bit clear that this is the northern hemisphere. Okay, that's why making the diagram is very important. So if I disregard the yellow line and only talk about the green great circle track, this is 080, which is the initial great circle track, and this is 083. All right. So this is the diagram as per the question. Now, what do I see from this diagram? I can see that this angle, which is what? My conversion angle is 3 degrees, right? 083 minus 080. So if this is 3 degrees, this will also be 3 degrees. Conversion angle is on both sides. Now, what do I need to know? I need to know the initial great circle track from B to A. So from B to A, I want to know this track, the initial great circle track. So to find that track, I go on the longitude, continue in the clockwise direction till I hit the arrow. So I need to know this big white angle. Now I was talking about a property of parallel lines earlier. So that property says that if there are any two parallel lines, and let's say this line is cutting across the two parallel lines, so this angle and this angle will be equal. If this is x, this will also be x. This property is known as alternate interior angles. Okay, now I'll use the same property in this diagram. So let's say the white longitudes are the two parallel lines and the red line is cutting across it. How much is this angle? The yellow angle. It is 083. So what will be this angle? This angle will also be 083, right? Now to know the big white angle, I need to know three angles. One is this yellow angle. Two is this blue angle, which is the conversion angle, and 3 is this magenta angle. So how much do you think will this magenta angle be? Exactly, it will be 180 degrees because longitude is just a straight line. So what does this white angle come out to be? It is 180 plus 83 plus 3, which is what? 266 degrees. All right. So my great circle from B to A is 266 degrees, and it is the northern hemisphere, which we confirmed by making the diagram. So the answer to this will be 266 northern hemisphere alpha. Now, if you want to confirm if you are
Perfect.
correct
Looking
or
at the
not,
next question now.
so second question. In the northern hemisphere, Rhumb line track from A to B is 230, convergence is 6 degrees, and the difference in longitude is 10 degrees. What is the initial Rhumb line track from B to A? All right. So first of all, let's say this is A. A to B is 230. So where is 230? Somewhere in this direction. So let's say my B is over here. Okay, so A to B, let's draw the Rhumb line track. And we are in the northern hemisphere. So the great circle track will look somewhat like this. Let's draw the longitudes. A, B. What information do I have? I know that the Rhumb line track from A to B is 230. So this angle is 230. If I draw the arrows will be from A to B. Okay. What do I need to know? The initial Rhumb line track from B to A. So I need to know this magenta angle from B to A Rhumb line track. All right. So very straightforward. Just tell me one thing. What is this big yellow angle comprised of? It is comprised of two angles. One is this 180 degrees and this small angle, right? So if the blue one is 180, the yellow is 230, how much will the magenta be? It will be 230 minus 180, which is equal to 50 degrees, right? So this magenta angle is 50 degrees. And now tell me one more thing. If this magenta angle is 50 degrees, what will this magenta angle be? If you look at the diagram properly, these two are nothing but alternate interior angles. Two parallel lines, one line cutting across. If this is 50, this will also be 50. So magenta angle is 50 degrees. And that is the answer. So from B, if I start from the longitude towards A, the Rhumb line track is 050 degrees, which is a very straightforward question. But to confuse you or to waste your time, there is some extra information given in this question. What is that information? It is the convergency and the Shillong. Because looking at the question, what will someone do? Someone will straight away put the convergency formula, Shillong into sine of mean lat, and then they'll think about, okay, Shillong is 10, C is what, 6. So let's find the latitude. But what is the use of it? It is not useful at all. It's just wasting your time. So just draw the diagram, just fill in the information that is given in the question, and half of the question is solved then and there. Okay. Looking at the third question now. Great circle track joins A and B. What is the difference between the great circle track at A and B? Okay. First of all, let's understand this language. Difference between the great circle. What is the difference between two great circle tracks? Tell me. It is convergency. Great circle arrival minus great circle departure is convergency, right? Or difference between any two great circle tracks is convergency, like we saw in the previous video. So in this question, they're asking us to find the convergency. All right. So now let's draw the diagram. I have 2 points A and B. All right, here I have latitudes and longitudes. Let's say A is somewhere here. Okay, this is what? 59 south, 141 west. What is the latitude of B? B is 61 south, okay, which will be below A or south of A, and 148 west, so west of A. So it will be southwest of A. So B is, let's say, somewhere here. Yeah. It is 61 south, 148 west. All right, so I have 2 points, A and B. Do I need to draw the diagram? Not necessarily, but let's draw the diagram because I just want to find the convergency, right? So two longitudes, and since in the southern hemisphere, this will be the great circle track. I don't know if I want to talk about A to B or B to A, so I'm not putting any arrows in this question. All right. What do I need to find? I need to find the convergency. Convergency is Shillong into sine mean lat. What is my Shillong between both of these points? 141 west and 148 west. It is 7 degrees into sine of mean lat. Okay, so if this is 59 south, this is 61 south. What will be the mean latitude? It will be 60 south, right? So it will be sine of 60. So 7 into sine of 60, convergency comes out to be 6 degrees. All right. So the difference between the great circle track A and B is 6 degrees. Now, if you look at the options, it is asking you if it is increasing or decreasing. How do I find if it is increasing or decreasing? I draw this table. North, south, east, west, I, D, D, I. So what is happening? We are in the southern hemisphere and A to B we are traveling towards west. Okay, let's say it is A to B because we've been asked the difference between the great circle track at A and B. Okay, so we are going from A to B. A to B means we are traveling west. So south and west it is I, which is increasing. So the correct answer is increases by 6 degrees, which is alpha. Understood? Very easy question. It's just the language which you need to understand. Diagram was not important, but later if you want to think about going east or west, then this diagram may come handy. So it's always better to draw a diagram. It's just a very small diagram. You can easily visualize initially when you solve the questions. Where is 59 south? Where is 61 south? How do I find the mean latitude? If I'm going east, if I'm going west, all those things. Okay? So southern hemisphere going west, it increases by how much? Convergency is 6 degrees, so it is increasing by 6 degrees. Perfect. Question number 4. Great circle bearing of position B from A in the northern hemisphere is 040 degrees. If the conversion angle is 4 degrees, what is the great circle bearing of A from B? All right, so just looking at the first part of the question, A to B, 040. So if this is A, this direction is somewhere 040. Let's say this is B. Two longitudes for B and A. And northern hemisphere, so it will look like this. What else? What else? The arrows. So I'm going from A to B. These will be the arrows. Now, what all do I have? I have the great circle bearing, which is 040. So this angle from A is 040 degrees. And what do I need to know? I need to know the great circle bearing A from B. So from B to A, what is the great circle bearing? Let's say this magenta angle. From B to A, great circle bearing is a question mark. Okay, very easy question because I have the conversion angle. Conversion angle is 4 degrees, which is this blue angle. Now, alternate interior angles, right? How much is this big red angle? 040 plus 4, 44 degrees. If this
If
angle is
this angle is
44,
44,
can
can
I
I
say
say
this
this
angle
angle
is
is
44
44?
too? Yes, alternate interior angles. Now, if this is 44, this we know is 180, and this angle we know is 4 degrees, which is the conversion angle. So, how much will the big magenta angle come out to be? To be 180 plus 44 plus 4, which is 228 degrees. Okay, so which is alpha. Great circle A from B is 2 to 8 degrees. So I've purely solved this question using the diagram, right? So that is why drawing diagrams are very, very important. And I personally feel that when you're starting off with this topic, just keep multiple colored pens with you or use an iPad just like I'm using. Because when you use different colors for different angles, things become easier for you. It is very easy for you to relate to the angles. Like in this, I know the big magenta angle is comprised of three angles. The first blue angle is 180. Second red angle is equal to the red angle which is on the opposite side, 44 degrees. And the other blue angle is equal to the blue angle on the other side, which is conversion angle. So just use different colors. It becomes easy for you to understand. Okay, four questions done. Looking at the next one. An aircraft follows a great circle track in the northern hemisphere. At a certain moment, the aircraft is at a position on the great circle where the great circle direction is 270 degrees. Continuing on the great circle, track will decrease, latitude will decrease, and blah 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 blah. Okay, let's just take 2 points in the northern hemisphere. These 2 points, A and B. Okay. This is the Rhumb line track. Since it is another hemisphere, great circle track will look like this. These are two longitudes. Now, so aircraft is following a great circle track, and some place the direction of that great circle is 270 degrees. Okay, so let's say my aircraft is taken off from A. What is the direction right now? Let's say this is 045 degrees. Okay. Now I'm continuing on the same great circle. What is the direction now? 060 degrees. My card is over here. What is the direction now? 090 degrees. I'm continuing from A to B. Direction 120 degrees. And so on. So if my aircraft is going from A to B, these will be the directions 045, 060, 090, 120, and so on. But if my aircraft is flying from B to A, the directions will be in the opposite direction. Let me just get rid of this. So let's say I've taken off from B. I want to go to A following this great circle track. So B to A, this angle looks like 330 to me. I'm continuing. This looks like 300 to me. Okay, now I'm over here. This looks like 270 to me. Yes, 270. That's what the question is talking about. So the aircraft is at a position on the great circle where the great circle direction is 270 degrees true. Okay. So my aircraft is over here. And continuing on the great circle, what will happen to the track angle? So let's just draw it. I'm over here now. So what is the direction? 245, let's say. So what has happened over here? The track angle has decreased, right? So the track angle has decreased. Bravo, Charlie, incorrect because they say increase. So the correct answer is either alpha or delta. Let's look at the latitude. So what will happen to the latitude? When my track was 270, what was my latitude? This was the latitude. Now when I'm continuing from B to A at a point where the track is 245, what is the latitude? The latitude is this. So what is happening to my latitude? It is decreasing, right? Earlier, if I was at, let's say, 30 degrees north, now I'm probably 20 degrees north. Yeah, just an exaggeration, but you get the idea, right? So my latitude is decreasing. So the correct answer comes out to be alpha. Understood? Very straightforward question, but you need to have this picture in your mind. If we are coming from east to west or from west to east. For that, just draw the diagram and just use hit and trial method. Initially, when you're solving questions, just solve a lot of questions, keep making different scenarios, and everything will fall into place. Just like I did for this question. First, I solved from A to B. So from A to B, the directions were as follows. Now that does not make sense as per the question. As per the question, the great circle track has to be 270 at some point. So that means I'm going in the wrong direction. Let me go from B to A. When I'm going from B to A, yes, it does make sense. There is a point where the track is 270, which is my great circle track, right? And what is happening after that? It is reducing and I'm coming down. Down means my latitude is also reducing. So another example of why drawing the diagram is important. There will be questions in which diagrams will not be required. I'll tell you, but here it is required. Okay. So looking at the sixth question, which of the following difference in latitudes will give the greatest difference between the initial great circle track and the mean great circle track between 2 points, which are separated by 10 degrees Shillong. Okay, so in this question, I know that there is no use of making any diagram because I don't have any information. I don't have 2 points. It's just theory. So they're asking me which of the following difference in latitudes will give me the greatest convergency. How do I know it is convergency? Because they're asking me about the difference between the great circle initial and the mean great circle track. I know the difference in great circle tracks is convergency. So if you didn't understand this question, it says that which of these two latitudes will give me the maximum convergency. Okay, so writing the formula for convergency, Shillong into sine of mean latitude. What all do I have? I have Shillong, 10 degrees. Now, into sine of mean latitude. How do I find mean latitudes? To find mean latitudes, I take the two latitudes, add them up, and divide by 2. So let's find the mean latitudes of all these four cases. So for 30 degrees south and 25 degrees south, the mean latitude will be 30 plus 25, which is 55, divided by 2, which becomes 27.5 degrees south. Second one, 30 degrees south and 30 degree north. So if this is your equator, one latitude is over here and the other latitude is over here. So what do you think will be the mean latitude? It will be the equator, which is 0. So the mean latitude in the second case will be 0 degrees north south. Third one, 60 degree north and 55 degree north. So 60 plus 55 divided by 2, it becomes 57.5 degrees north. And the last one, 60 degree north and 60 degree south, same as 30 degree north south, the mean latitude is 0 degrees. Now, what do I have to do is that I have to take all these four cases and put it in the formula to see which case is giving me the maximum value of convergency. Easy. Now, instead of putting each and every value, I'll just use basic common sense. Sine 0 is 0. So these two cases are out. Okay, so that means 30 degree north south is out, 60 degree north south is out. They're giving me a convergency of 0 degrees, which is at the equator. Now, sine of anything increases as the value increases, right? So, which one will give me a bigger value of convergency, 27.5 or 57.5? It will be 57.5. So, if I put sine of 57.5 and I find out the convergency, the value which I'll get will be the maximum. So the maximum value of convergency will be between 60 degree north and 55 degrees north. So if the value of mean lat is more, the value of convergency will be more. As simple as that. Okay. So now some people would say that it is asking for the difference between the initial great circle track and the mean great circle track. Whereas I taught you it is initial and final, right? But it doesn't matter. The difference between the initial and final and the initial and mean, both are the same things. Obviously, the values will be different. But if the difference between initial and final is more, then the difference between the initial and mean will also be more. So don't get confused. In this question, they're just asking you that which of the following latitudes will give the maximum value of convergency. Perfect. Six questions down. Looking at the next one. The automatic flight control system is coupled to the guidance outputs of an inertial navigation system. Which pair of latitudes will give the greatest difference between initial track readouts and the average true course given? In each case, a difference of longitude of 10 degrees. Okay, it's the same thing, but the confusing part is what is all this automatic flight control system coupled to inertial navigation system? So, the automatic flight control system is nothing but the autopilot system of the aircraft, and the INS or the inertial navigation system is a system used for navigation. That's it. Okay. So, INS, IRS, you'll read when you talk about instrument navigation. The only thing which you need to know right now is that whenever an aircraft is following guidance from an INS or inertial navigation system and using the autopilot to fly those inputs from the INS, it follows a great circle track. Okay, so whenever you're flying using inertial navigation system, you follow a great circle track. So in this question, they're again talking about the maximum difference between the initial great circle track and the average great circle track. So it's same like the previous question, right? So I write the formula for convergency. I have intentionally put these two questions same just to show this part, the automatic flight control system and the inertial navigation system. Because most of the people don't know what all this is and they just get stuck. So it's exactly the same question like the previous one, right? In this, the options are 60 north to 60 north. Okay, so the average becomes 60 north only. 60 north to 50 north, average is 55 north. 30 north, 30 south, which is 0 degrees north south, and 30 south, 25 south, which is 27.5 south. So the maximum value of mean latitude comes out to be 60 north. So alpha will be correct. So if I put in the formula, Shillong 10 into sine 60. So this will be the value of convergency, which will be the maximum out of all these four situations. Understood? Just like the previous question, just the English is different. Okay. Okay, so looking at the next question, a Lambert conformal conical chart has a constant of the cone of 0.85. The initial course of a straight line track drawn in this chart from A to B is 0.43 at A. At B, it is 0.55. What is the longitude of B? Okay, so before I solve this question, I will tell you something about the Lambert conical chart. I'll assume you haven't started or you haven't covered maps and charts topic yet. So in a Lambert conformal conical chart, there are two formulas which you need to know. First one is of constant of cone. So what is constant of cone? Constant of cone is denoted by n and it is equal to the sine of the parallel of origin of this chart. In this chart, there are standard parallels and a parallel of origin. So n, which is also the constant of cone, is sine of parallel of origin. And the value we have is 0.85. Another formula for this chart is of convergency. So convergency in a Lambert conformal conical chart is Shillong into sine of parallel of origin. Okay. In this, you do not have sine of latitude or sine of mean latitude. In this, it is sine of parallel of origin. All right. So now this part can be n. Okay. Now another important thing in this chart is that a straight line on a Lambert conformal chart is a great circle track. So great circle tracks are straight lines. That's why in the question it is given that the initial course of a straight line track from A to B is 0.43 and at B is 0.55. So we are given two great circle tracks from A to B and at B. So what are we actually given? We are given the convergency. So what is the convergency? Convergency becomes great circle arrival minus great circle departure. So it is 12 degrees. So this becomes your convergency. Now using the formula for convergency on a Lambert chart, it is 12 is equal to Shillong, which we do not know, into 0.85. Why 0.85? Because this part is equal to n and n has a value of 0.85, which is the constant of cone. Okay, so when I solve this, my Shillong becomes 12 divided by 0.85, which is a value of 14 degrees. Okay, now I have the Shillong, I have the coordinates of A, I need to find the coordinates of B, or not the coordinates, just the longitude of B. So let's just draw A and B. For example, this is A. From A to B, it was approximately 0.45. So in this direction, let's say B is over here. I'm not considering a great circle track or a Rhumb line track. I'm just drawing it for my own reference. So if A is on the left, B is on the right, longitude of A is 50 west, what will be the longitude of B? So whenever I'm stuck in this situation, the only diagram which comes into my mind is this. Looking at the Earth from the top, this is my prime meridian, 0 east west. This direction east, this direction is west. Okay. Now, what all do I have? I have A at 50° west. 50° west will be somewhere here. And my Shillong is 14 degrees. Now, 14 degrees where? Towards east or towards west? So, A to B, I'm going towards the east. So, I will come towards the east. I will follow this arrow or this direction. So, let's find, let's say, this longitude. This is 14 degrees. So, this becomes 50 minus 14, which is 36 degrees west. This is the longitude of B. And the correct option is Bravo. Whenever you are given one longitude and want to find the other longitude using Shillong, always draw this diagram. Because if you draw this diagram, there is no way your answer can be wrong. Just follow the two directional arrows on the bottom and you will get the correct answer. I still draw this diagram. Okay, so very straightforward question, easy question, provided you know this part. And this is covered in maps and charts. So whenever you're covering that topic, just read about these two properties, or I would say these two formulas. All right. Question number 8. Aircraft travels from A to B using the autopilot connected to the aircraft's inertial system. It's the same. So the aircraft is following what? A great circle track. Coordinates of A, coordinates of B have been entered. True course of the aircraft on its arrival at B to the nearest degree is. Okay, let's plot A and B. So A is over here. Let's say 45 south, 010 west. B is also on 45 south and it is 030 west. So B will be west of A on the same latitude. So this is B, 45 south, 030 west. Okay, A and B on this parallel of latitude, the two longitudes, and we're talking about the southern hemisphere. So this will be the great circle. If I'm going from A to B, these will be the arrows. Now, what all do I have? Aircraft travels from A to B using an inertial navigation system. That means the aircraft is going to follow a great circle track. True course of the aircraft at B. Okay. So when my aircraft left from A, the great circle track would be this much. Okay. It is less than 270. And when my aircraft reached B, the great circle track will be this much, which is more than 270. Okay. So can I find the green angle? Yes, I can. For that, what do I need? I need to know the conversion angle. So if I find this white angle, I can find this angle right here. And to find the big green angle, I need to find two angles. One is this blue angle and the other is the white angle. So the blue angle is how much? It is 270. Why? Because both the points are on the same parallel of latitude. And what about the white angle? Let's find the white angle. So white angle is my conversion angle. Conversion angle is half of convergency. Half of convergency means half of Shillong into sine mean lat. What is sine mean lat? I'll just write sine lat for now. So half into Shillong, 010 and 030, Shillong of 20 degrees into sine of 45. So it becomes 7 degrees. So my conversion angle is 7 degrees. And since this angle is 7 degrees, this angle will also be 7 degrees. And to find the big green angle, it will be blue angle, which is 270, plus the white angle, which is 7. So it becomes 277 degrees, which is alpha. All right, here, if we had the value of the magenta angle, I just had to add the convergency to it. But since I did not have the magenta angle, what I used is the conversion angle. So I drew the blue angle, which is 270 degrees, looking at the diagram, and I just added 7 degrees. So conversion angle 7 plus the blue angle of 270 becomes 277. All right, next one. I think this is the last one. So the great circle track measured at A from B is approximately, all right. Okay, so A, 45 north, 010 west. B, 45 north, 019 west. Both are in the northern hemisphere. So if these are the two longitudes, this will be the great circle. A to B direction will be this. Now, what do I want to know? Great circle track measured at A from A to B. Okay, great circle from A to B. will be this angle starting from the meridian in the clockwise direction till I hit the arrow. So great circle from A to B is this much. All right, again the same thing. To find this big magenta angle, I need to find two angles. One is this angle and the other is this angle. So what is the yellow angle? How much is the yellow angle? 270. What about the white angle? Let's find it out. So white angle is what? Conversion angle, which is half of convergency, which is half of Shillong. How much is Shillong? From 10 to 19, 9 degrees into mean latitude. Mean latitude is sine of 45 only. Mean latitude is 45. So my conversion angle becomes 3 degrees. This angle is 3 degrees. So the magenta angle becomes 270 plus 3 degrees, which is 273 degrees, which is delta. Okay, so these are all the kind of questions from Convergency which may be asked in the exams. I hope you understood all the questions. And if you have doubts in any of these questions or any other questions you come across in Convergency, feel free to hit me up via DM on Instagram or via email. So thanks for watching, and I'll see you all next time.